In this question, a heavy particle is projected from a point at the foot of a fixed plane inclined at angle of 45 degrees to the horizontal in the vertical plane containing the line of greatest slope through the point. If phi is greater than 45 degree, is the inclination to the horizontal of the initial direction of the projection. For what values of tan phi will the particle strike the plane? Horizontally, second at right angle. So this question is divided into two parts. We are going to find out what will be the value of the tangent of phi, where phi is the angle given with respect to. So let us draw for the first part. So this is the inclined plane and its angle is given as 45 degree, and the particle is projected in this direction so that it reaches the point P, and this angle is given as phi. So let us say this is P, this is M, and this is O. So as this is 45 degree, so with respect to tangent of phi, tangent of 45 will be equal to PM divided by OM. So tan of 45 is 1, so we can see that PM will be equal to OM, and in this case we assume that let that be equal to H. So this value will be equal to H, and this height will also be equal to H. And in the first case, we are supposed to find out such that the particle is at the horizontal. So we can say that the velocity is in this direction, and which is given as u cos of phi angle. So we state that let the particle is projected from point O with the velocity u. So it is projected with the velocity u with velocity u, and it strikes the point P after time t seconds. So in the first case we are supposed to find out if the particle strike the point P horizontally. If the particle strikes the point P horizontally, if it strikes the point P horizontally, we can say that vertical component of the velocity is 0. Vertical component is equal to 0. Okay. So next we find out the horizontal component of the velocity u. So we can write it as horizontal component of velocity of projection. So we can write this as ux is equal to u cos of phi. Similarly, we can find out vertical component of the projection. Vertical component of velocity of projection. So we can write that u of phi is equal to u sine of phi. Therefore, the horizontal distance traveled by the projectile particle in time t. So we can say that horizontal distance traveled in time t, and that will be nothing but om. So we can write this as om is equal to ux multiplied by t. We already know ux is u cos of phi, multiplied by t, or om is equal to h. So we can write this as h is equal to u cos of phi t. Let us call this as equation number 1. In the vertical direction, the final velocity Vy will be equal to initial velocity in y direction plus acceleration in y direction multiplied by time t. So we already stated that the vertical component of the velocity at point P will be equal to 0. So this basically means that Vy will be equal to 0 at point P. So from here we can say that Vy is equal to 0, Ay is equal to minus g, and Uy is equal to u sine of phi. So you put all these values, we get this as 0 is equal to Uy is u sine of phi minus g t, and from here we get the equation as u sine of phi is equal to gt, and let us call this as equation number 2 equation. And similarly, in the vertical direction, we can find out the distance traveled in vertical direction. So we can write s of y is equal to u of y t plus half a of y t square, and the vertical distance traveled, that is sy, is nothing but h. Sy is h. So we can write this as h is equal to uy is u sine phi multiplied by t minus half g t square. So now we can use equation number 1 and 2 to, let us call this equation as 3. This equation is equation number 3. So we can use equation 1 and 2 to solve the equation 3. So using equation 1 and equation 2 in equation 3. So h we already know is given as u cos of phi multiplied by t. This is equal to u of y is already written that u sine of phi into t minus half, and gt we already know is u sine of phi multiplied by t. So we can cancel out t as well as we can cancel out u. So we can write this as cos of phi is equal to sin phi minus half sin phi, and this is going to give us cos of phi is equal to 1/2 sin of phi, and this implies that tangent of phi is equal to 2. So this is the first part, in which if tangent of phi is equal to 2, the particle is going to be in the horizontal direction at point P. Now we come to the second part. In the second part, we once again draw the figure, which is almost same except the velocity component at point P. So this is the projection at u at angle of phi. This is 45 degree. This is OMP. This is H. This is also H. And the velocity component will be now in this direction, and its value will be equal to u sine of phi minus 45 degree, and we are also going to have a component of g that is in this direction. It is going to have two components. One will be vertical and one will be in horizontal direction. So this angle is 45. So we are going to get this is g cos of 45, and this will be g sine of 45. So again, if the particle strikes the plane at point P at right angles, the component of the velocity, or rather the velocity component parallel to the horizontal, which is nothing but also the plane, is 0. So this will be, so it means thus along the perpendicular to the plane, so we are going to have thus along perpendicular to the plane, the vertical distance sy, which is equal to u by t plus half a by t square. Now in the vertical direction, or rather we can say here in vertical direction. So in the vertical direction, the distance traveled sy is equal to 0 and uy is equal to u sine of phi minus 45. So if you put both these values in this equation, we get 0 is equal to u sine of phi minus 45 minus half. Okay, I forgot to mention our g, that is a of y will be equal to minus g cos of 45. So he can written as g cos of 45 multiplied by t and multiplied by t square. So we can write this as t is equal to 2 root 2 divided by g u sine of phi minus 45, and let us call this as equation number 4. And along the plane, which basically mean in horizontal direction. We can say that Vx is equal to ux plus ax multiplied by t, and in the horizontal direction, or we can say parallel to the plane, ux Vx will be equal to 0, that is final velocity at point P. Ux will be equal to u cos of phi minus 45, and ax will be equal to minus g sine of 45. So you put these values, we are going to get this as 0 is equal to ux is u cos of phi minus 45 minus g sine of 45 into t. We already know the value of t, so this can be further solved as this can be written as u cos of, this can be written as u cos of phi minus 45 is equal to g sine of 45, and substituting the value of t, that will equal to 2 square root of 2 divided by g u sine of phi minus 45. So in this case, g cancels out with g, u's go with u, so we will be left with cos of phi minus 45 is equal to sine of 45, that is 1 upon root 2 into 2 root 2 sine of phi minus 45. 2 root 2 and 2 root 2 also cancels out, So we will get this as tangent of 5 minus 45 is equal to 1 by root 2, and we can expand this tangent of 5 minus 45. We can write this as tangent of 5 minus tangent of 45 divided by 1 plus tangent of 5 tangent of 45 is equal to 1 by 2. Tangent of 45 is 1, so we get this as tan phi minus 1 divided by 1 plus tan phi is equal to 1 by 2. So cross multiply, we get 2 tan phi minus 2 is equal to 1 plus tangent of phi. So ultimately we again sort it out as tangent of phi is equal to 3. So it means when tangent of phi is equal to 3, the particle will be perpendicular at point P. Thank you.